When you think of the Olympics, do you think about sustainability? I bet you didn't even know that there is an Olympic House in Lausanne, Switzerland. And most definitely, you didn't know that the Olympic House is one of the most sustainable buildings on Earth right now, and the number one most sustainable building in Switzerland. Designed by 3XN architects and completed in 2019, it serves as the administrative and operational center for the International Olympic Committee. It is the primary workplace for IOC staff responsible for organizing and overseeing the Olympic Games, and it also includes an Olympic museum. In addition to receiving the LEED Platinum certification, Olympic House is the first to obtain the platinum level of the Swiss Sustainable Construction Standard, or SNBS for short. It has also been awarded the Swiss Standard for Energy Efficient Buildings. The concept for the Olympic House was number 1, integration, blending the green base of the structure with the natural setting of the surrounding park. Number 2, the focus of the athletes, shaping the house to be inspired by the movement of athletes. Its curved facades also help to minimize the visual impact of the building in the landscape and bring a maximum amount of light into the interior spaces. Number 3, peace, symbolized with the use of the solar panels on the roof, representing the shape of the dove landing in the park. Number 4, unity. Its central staircase resembles the Olympic rings and is designed to be in line with the concept of active architecture that encourages the movement of building users. One of the reasons why the Olympic House is one of the world's most sustainable buildings is thanks to the solar panels on the roof, which bring in 10% of the building's energy, making it energy efficient. The skylights on the roof also allow a lot of natural light to enter the building, reducing need for artificial lighting. There are also environmental controls that allow individual users to customize the temperature and lighting in their immediate workspace. Enhancement of biodiversity. More than 60% of the site area is open space and half of it is vegetated, with 150 trees added since before development. Only indigenous plant species are being used, with meadow areas that include pollinating plants and require lower maintenance than lawns. There are 2,500 square meters of vegetated roof and outdoor lighting which will be optimized to minimize light pollution. The architects also made it a point to use sustainable construction materials for construction. Significant efforts were deployed to screen all construction materials, equipment items, finishing materials, and furniture items so that they comply with strict environmental standards, such as low contents of potentially harmful substances, in order to guarantee very good indoor air quality. In addition to using sustainable construction materials, there was an innovative approach and the architects were able to reuse 95% of the materials from the original structures. Based on the elevation view, we can see the existence of a double facade with several key functions that enhance its overall performance and comfort. The first function of the double facade is to maximize natural daylight within the building. The fully glazed outer layer allows ample sunlight to penetrate deep into the interior spaces. This design reduces the need for artificial lighting during the day. Another vital function of the double facade is noise screening, serving as a noise barrier, effectively reducing external sound levels. This noise reduction ensures a quieter and more peaceful indoor environment. The inner layer of the double facade focuses on insulation through air tightness and triple glazing, designed to be airtight, preventing drafts and heat loss. Triple glazing on this layer improves thermal performance, maintaining comfortable indoor temperatures. This insulation promotes energy efficiency and a consistent indoor climate. Lastly, the outer layer of the double facade enhances the building's acoustic performance and safeguards the inner thermal facade. The outer layer is specifically designed to reduce external noise and vibrations. It also acts as a protective shield and contributes to a comfortable and tranquil indoor environment, preserving the energy efficiency of the building. But what is the main focus of the Olympic House's green strategy that we want to highlight? Well, the Olympic House prides itself on its use of renewable resources energy. They can be summarized as rainwater harvesting, which is the collection and storage of rain; thermal mass, which is storing heat and provide inertia against temperature fluctuations; lake water cooling and heating, which is the geothermal power technology; photovoltaic panels, which convert solar energy into electricity. Rainwater harvesting involves the collection and storage of rainwater in a 300-meter cube water tank. Collected rainwater can be used for various purposes, including irrigation, toilet flushing, and cooling systems. This sustainable practice conserves water resources and reduces the demand on municipal water supplies by 60%. Olympic House also benefits from thermal mass, the building's ability to store heat and provide stability against temperature fluctuations. Materials with high thermal mass, such as concrete, absorb heat during the day and release it slowly at night, reducing the need for heating and cooling and reduces energy consumption. The use of lake water heating and cooling, particularly deep lake water cooling, is another eco-conscious feature at Olympic House. Lake water cooling taps into the geothermal energy stored in deep lakes, using them as a heat sink for cooling systems and an environmentally friendly way to regulate indoor temperatures. The cooling system involves heat exchange with the underground environment, where lake water is pumped from a depth of 60 meters, ensuring a consistent temperature of 5 degrees Celsius. This deep lake water cooling system efficiently regulates temperatures within the building during hot periods, minimizing energy consumption and an environmental impact while maintaining a comfortable indoor climate. During the winter months, the heat pumps come into play by circulating water at a temperature of 35 degrees Celsius to distribute warmth throughout the building. This system has an impressive coefficient of performance, also known as COP, of 5. They effectively raise the temperature for heating purposes, utilizing minimal energy while providing a cozy and sustainable solution for maintaining comfortable indoor conditions. Last but not least, Olympic House harnesses the power of the sun through photovoltaic panels. Photovoltaic panels directly convert solar energy into electricity, which can then be directly consumed for building operations. They are installed on the building surface, covering about 1,000 meters square. They generate clean, renewable energy of approximately 200 megawatt-hour per year, or roughly equivalent to the usage of 60 Swiss households. This reduces dependence on traditional power sources by 35% less energy per year and lowers greenhouse gas emissions. Now, how does this green strategy help the Olympic House reduce its costs? The use of renewable energy has reduced the energy consumption by 35% per year. In addition to that, it is estimated that by the year 2085, the cost saved by the green strategies will exceed the expenses in building and maintaining them. Our analysis and calculations used to come to this conclusion can be broken down like this. Electricity bills. The cost for 1 square meter per year is about $1.44, bringing the total cost for the Olympic House to $13,500. Photovoltaic panel system. Total cost is $415,000 with an installation fee of $15,000. Maintenance fee. Maintenance fee for the Olympic House per year costs $500, meaning the cost for maintenance all the way until the year 2085 would be $462,500. The budget saved per year rounds up to about $7,300, totaling at a whopping $474,500 saved by 2085. In conclusion, for the rainwater harvesting, in the winter there is less sunlight and rain, and therefore uses stored water from summer where there is more sunlight and rain. As for thermal mass, in the winter, the materials absorb heat during daytime and release it during the cold nights, while in the summer, the materials absorb coolness during the nighttime and releases it during the hot daytime. For the lake water heating and cooling systems, heat pumps with a COP of 5 raise the temperature using water of 35 degrees Celsius during the cold winter times to distribute heat in the building, whereas in the summer, cold deep lake water from a depth of 60 meters and a temperature of about 5 degrees cools down the building. Lastly, for the solar panel systems, the excessive daylight in the summer stores energy, which is used for the winter times, where daylight is less. That is all, and we hope you found this video valuable and informative. Thank you.